Now, physical weathering is different than chemical weathering. In chemical weathering, chemical reactions occur. The chemical formula of these rocks and minerals will change, and it produces ions in solution and clay minerals. There are three main types of weathering or chemical weathering that we're going to talk about: dissolution, hydrolysis, and oxidation. These are by no means the only three. They're just the most important three that we're going to talk about. Now, every single one of these chemical reactions is sped up by the presence of carbonic acid. Carbonic acid forms when carbon dioxide mixes with water. There's carbon dioxide in our atmosphere. There's water all over our planet, so this happens all the time. And when carbon dioxide mixes with water, carbonic acid is created and the water becomes acidic. And when the water is acidic, this increases the rate of chemical weathering. And then also the rate is further increased. The production of carbonic acid is further increased in warmer temperatures. So this is why chemical weathering happens faster in tropical environments than it would in polar environments. So dissolution is one of the chemical weathering processes that happens faster when there is carbonic acid in the water. And dissolution occurs when water molecules physically and chemically cause the rock to dissolve. The water molecules are tearing apart those bonds, breaking the bonds of the rock, and causing those ions that used to be a part of the rock to float off into the water, right? So that rock is physically dissolving. And this occurs because water molecules are polar. This means that there's a slightly positive charge on hydrogen, a slightly negative charge on oxygen, and those charges are going to be attracted to the ions of the rock, right? So the ions of the rock are going to stick to that charged water molecule and be taken away. And this is how rocks like limestone can very easily dissolve. You can see the texture of this rock here, where anywhere there's a little crack where water can settle, there's a lot of dissolution, and that crack just gets bigger and bigger and bigger. Okay. So what's physically happening here? For example, dissolution is in limestone. When you add carbon dioxide to water, you create carbonic acid, right? If you add carbonic acid to limestone, then that limestone is going to dissolve, creating sinkholes and caves and what we call karst topography. Karst is just the widespread dissolution of limestone, right? And it can look like this, right? Where you can get dissolution of the surface. It can also, if it's below the surface, can cause caves, caverns, things like that. So that's dissolution, right? You add water to a rock and that rock dissolves, so solid material is lost. Hydrolysis or hydration is similar in that you're adding water, but now solid material is not lost. Solid material is just changed. So weak carbonic acid, again, is going to further this reaction. And when material is chemically weathered in this way, it actually draws down carbon dioxide. And this is one of the things that can slow down global warming of our planet, right? Because carbon dioxide is consumed in the weathering of rocks. Okay. So in hydrolysis, as I said, water is added and the solid changes. So water is added, for example, to feldspar, and then the water, the H2O, is physically incorporated into the composition of the product. In this case, it's kaolinite. So in this example, you start with a solid, you add water with carbonic acid in it, and you get out another solid, a different solid, plus ions in solution. And those ions in solution, as we know, can be transported downstream, eventually end up in the ocean, which is what causes the ocean to be salty. So we've talked about dissolution and hydrolysis. Now we're going to talk about the third type of weathering, oxidation. This is when oxygen is bonded to ions and it causes those ions to lose their electrons, right? So for example, if ferrous iron, iron 2+, bonds to oxygen, that ferrous iron might give up an electron to that oxygen, causing the ferrous iron to oxidize, become more positive, and turn into ferric iron. And when this happens, it rusts. So in this image, you can see the pyrite crystals that has iron inside of it. It's an iron sulfide. And when that iron is oxidized, meaning it's bonded to oxygen and it loses an electron, then the pyrite starts to rust. And you can see those rusty weathering rings around each of these pyrite crystals.